Protein electrophoresis. In a polyacrylamide gel electrophoresis for proteins, the denaturing conditions are obtained with beta-mercaptoethanol, SDS detergent, and boiling temperature. From the top, proteins migrate through a stacking gel. This is their first gel, and it is a fast migration. They run through it until they reach the resolving gel, the last and slowest gel. After the electrophoresis is finished, to visualize the proteins, you must stain them with Kumasi blue. Electrophoresis allows us to separate charged molecules in solution as they migrate through a solid matrix. To analyze big biological molecules such as proteins, we use polyacrylamide gel electrophoresis, PAGE. You will use denaturing conditions, which are the most commonly used in the laboratory. To denature the proteins, they have to be mixed with a sample buffer that contains the reducing reagent beta-mercaptoethanol and the denaturing detergent SDS. Beta-mercaptoethanol dissociates the disulfide bonds in the polypeptides. The detergent SDS firmly binds to polypeptides, giving them a uniformly distributed negative charge. After adding these reagents, the solution is boiled to assure protein denaturation. By using this method, you can only separate the molecules by their molecular weight, since all the proteins are charged negatively. In this technique, proteins migrate through two different polyacrylamide gels. The one on the top is the stacking gel. The denatured and negatively charged peptides migrate easily in it until they reach the resolving or running gel at the bottom. Since the resolving gel is more concentrated and has a higher pH, peptides run slower and their migration can be compared at a higher resolution. This electrophoretic technique, called SDS PAGE, allows us to estimate the molecular weight of a polypeptide. To determine the molecular weight of a problem protein, you have to compare its migration to that of polypeptides with known molecular weights called standards. The aims of this activity are to prepare the system of polyacrylamide gels to separate proteins, to load the proteins and run them in the gels by electrophoresis, to stain the gel and then destain it to visualize the proteins. The solutions for this activity are 10 ml of acrylamide bis, 30 to 0.8 solution, 200 microliters of 2 times sample buffer, 3 ml of stacking gel, 4 times buffer, with pH 6.8, and 5 ml of resolving gel, 4 times buffer, with pH 8.8, 200 microliters of 10% ammonium persulfate, 50 microliters of Temid, 2000 ml of running buffer, 30 ml of Kumasi blue staining solution, and 30 ml of destaining solution, 10 ml of isopropanol, and 15 ml of triple distilled water. The materials for this activity are an electrophoretic chamber, gel casting unit and base holder, power supply with cables, spacers and glass plates, P20, P200, P1000 micropipettes and tips, Eppendorf tube holder, 1.5 ml Eppendorf tubes and 15 ml Falcon tubes, vial, heat-proof mat, tripod and Bunsen burner, centrifuge, orbital shaker, petri dish, spatula, gloves, paper towel, tips container, and ice. Remember to wear gloves during the whole procedure because non-polymerized acrylamide can produce neurodegeneration. Set the glass plates with the spacers. Place the glass plates on the gel casting unit. Seal the unit with the screws. Put the system on the base holder and secure it. To prepare the resolving gel at an 11% concentration, add the following to a Falcon tube with a P1000 micropipette, 2.55 ml of the acrylamide bis solution, 1.75 ml of resolving gel buffer, and 2.7 ml of distilled water. To catalyze the polymerization, add 30 microliters of APS with a P2000 micropipette, and with a P20, add 10 microliters of Temid. Mix by inversion several times. Immediately, use the P1000 to add the gel solution to the space between the two parallel glasses. Leave about 3 centimeters before the end of the plates to add the stacking gel afterwards. Add an isopropanol layer on top to create a flat surface. Let the gel polymerize at room temperature for about 20 minutes. Pour off the isopropanol and dry the glasses with a paper towel. To prepare the stacking gel at a 5% concentration, add the following to a falcon tube: 0.44 ml of the acrylamide bis solution, 1 ml of stacking gel buffer, and 2.6 ml of distilled water. Add 30 microliters of APS and 10 microliters of Temid. Mix by inversion several times. Immediately pour the solution between the 2 glasses and above the stacking gel. Quickly but carefully insert the comb to form the wells where you will load the protein samples. Let the gel polymerize at room temperature for about 20 minutes. At the same time, prepare the samples in the 5 Eppendorf tubes. They should contain 20 micrograms of protein, so add 2 times sample buffer enough to reach a 1-time concentration. Keep the samples in ice. When the polymerization has occurred, carefully remove the comb. Make sure that the wells are well formed. Gently remove the base holder and place the system in the electrophoretic chamber. Add the running buffer. Place the Eppendorf tubes in the holder and fix the lid with screws. Heat the tubes under the Bunsen burner in boiling water for 5 minutes. Spin the samples in the centrifuge. Load each sample into a well of the gel with a P20. In addition, load the molecular weight standards in one well. Once all the samples have been loaded, connect the electrodes of the apparatus to the power source with the plus pole to the red end. Start electrophoresis by applying a constant 80-volt field. After about 15 minutes, when the samples have reached the running gel, increase the voltage to 120 volts. After around 2 hours, the blue tracking dye should reach the bottom of the gel. At this moment, stop electrophoresis, turn off the power, and take the system out of the chamber. Separate the 2 glasses with the spatula. Use it to cut the stacking gel. To visualize the proteins, place the gel in a petri dish and soak it with the protein staining solution in the orbital shaker for about 30 minutes at room temperature. The proteins will be stained blue and so will the gel. To visualize the proteins, you have to destain the gel with a suitable solution in the same conditions as the staining procedure. Perform this for at least 1 hour until the proteins are clearly distinguished. Put the gel on top of a transilluminator with visible light and take a picture of it. With gloves on, first prepare the resolving gel and pour it between the glasses. Then prepare and pour the stacking gel and insert the comb carefully. Boil the protein samples and load the wells with them. Run electrophoresis first at 80 volts and then at 120 volts. Stain and destain.